In math, players try to turn a whole number into a fraction, and they do this because they know fraction times fraction is the same as numerator times numerator and denominator times denominator. So they would say 8 is the same as 8 over 1. And so now we have both fractions. Now it's just 3 times 8 and 4 times 1, which is 24 over 4, which is also 6. Now there's actually a shortcut to this. When you multiply a fraction by a whole number, you do numerator times whole number and keep the denominator. So this would really be just 3 times 8 all over 4, which is 24 over 4, which gives you the same answer. But wait, why this rule? Why does this rule work? Let's go back to the equation. Notice that 3 over 4 is the same as 3 divided by 4, which is the same as 0.75. Now back to that 3/4, we use the rule a over b times c is equal to a times c all over b. Now here, let's apply this to our decimal, 0.75 times 8. But hold on, there is no fraction here. We only have a decimal. So how can we actually simplify this? Well look, 8 is actually a power of 2. That is just 2 cubed, which is 2 times 2 times 2. Now since the operation is positive, the order doesn't matter, or we can just solve from left to right to make it easier. Now remember, a number multiplied by 2 is the same as a number added to itself. So 0.75 plus 0.75, well, if you do place value, you get 1.5. 1.5 times 2, that's 1.5 plus 1.5, which is 3. And now it's much easier since we have two whole numbers, and then we just simply say it's just 6. You can see that two of these methods actually end up with the same answer, and expressions like these always work with that method. So that's why that rule became valid.